Hello, welcome to Chapter 2, Homework Questions 48 through 42. Question 48, the graph at the right represents the number of tiles in a tile pattern. Part A, based on the information in the graph, how many tiles are being added each time? Pay close attention to the scale of the axes. So we want to find two nice points. We can start at the y-axis and then find another one, but also pay attention to the scales as it suggested. So each one of these on the y-axis goes up by 2. So this would be 2, 4, and then on the x-axis it goes over by 1. So if it goes up 4 and then over 1, that means we're adding 4 tiles each time. On B, how many tiles are in figure 0? So look right here on the y-axis, and since we're going up by 2s, you got 10, 12, 14, 16. So we have 16 tiles. Part C, write the equation of the tile pattern. Well, now that we know the growth rate, we know it's y equals 4x, and we also know figure 0 is 16, so we got y equals 4x plus 16. And then on part D, how would the line change if the pattern grew by 12 tiles each time? So how would the line change? The line would get steeper if we're growing by more tiles than 4. So we can just say that the line would be steeper. And that answers those 4 questions about the graph. Question 49. On graph paper, graph the line that goes to the points negative 6, 3. So let's go ahead and plot the point negative 6, 3 and negative 3, negative 1. What is the slope of the line? So let's go ahead and graph that line the best we can. You guys can use a straight edge for yours. What is the slope? Well, let's just do our slope triangle. So we're going up 4 units, and then to the left 3. So our slope is negative 3/4. Let's try that again. We're going up 4. So how about 4 over negative 3, or negative 4/3? What is the y-intercept? Well, if I continue this pattern, it looks like it'll intersect right here at 0, 5, 0, negative 5. And then what's the equation of the line? Well, now that we found those two pieces of information, we know the equation is y equals negative 4/3 x minus 5. So we have the rate of change of the slope and the y-intercept. Question 50. Solve each of the following equations. On the first one, we can subtract 2x from both sides. That will leave us with 8 equals x minus 4. Then we can add 4 to both sides, and that is x is equal to 12. On the second one here, probably give myself a little bit more room, I'll subtract the 1.5w, so that'll leave us with 3 equals 3 plus 0.5w, and then subtract the 3 to both sides. 0 is equal to 0.5w, divide by 0.5, and w is equal to 0. On part C, we can combine our terms, 48 and 23, so 71, subtract 71, and that'll give us negative 64, divide by 8, and we get negative 8. And then on D, we can combine our like terms on the right side to get 6x plus 17. Subtract 6x, and we'll notice that the variable term did go away, and we're left with negative 21 is equal to 17, which is not a true statement. So therefore, there are no values of x that will solve this equation, so we say no solution. Question 51, write an equation for the line containing the points shown in the table. So one thing I noticed right away is that we are given the y-intercept. So if we can find the slope, then we can write the equation. So I'm going to choose 2 points and rewrite them. I'm going to do negative 2, 5, and then 1 comma negative 7. So I chose this one and this one. And you can choose any 2 points to find the slope. So my slope is my change in y, 5 minus negative 7, over my change in x, negative 2 minus 1. So 5 minus negative 7 is 12. Negative 2 minus 1 is negative 3. 12 divided by negative 3 is negative 4. So we have the information to write the equation. Y is equal to negative 4x minus 3. Once again, that minus 3 at the end comes from the y-intercept. Question 52. Which graphs below have a domain of all real numbers, which have a range of all real numbers, and then are they functions? So in part A, as your graph continues to go in this direction, it continues to go left and right. So your domain on this one would be all real numbers. The range on this one, as the arrows show, they continue to go up and down. So your range is your y-axis. Are you going to miss any points in terms of the graph going up and down? And you are not. So therefore, the range is also all real numbers. There's no max or min on either side, up or down as well. So is it a function? Yes, it is. There's no x value that goes to more than one y value. B, your domain will be all real numbers. Same kind of reason for the last one, is that this graph is going to continue to go left and right and cover the entire x-axis. The range is not all real numbers because it stops right here. It has a maximum value, and so therefore it's not going to go any higher than that. But it still does represent a function. So once again, every x has its own y. And I'm going to go ahead and write, even though it doesn't say, I'm going to go ahead and write the range. It's a nice way to practice. And since the highest point here is 6, the range would be all values of y that are not greater than, that's a max, so less than or equal to 6. And then once again, it is a function. A little extra there for you. And then on C, your domain, now once again, on your x here, this goes until right here. So it doesn't go any farther to the left. So the domain is not all real numbers, but for extra practice, we'll write what it is. So that's at negative 2. So the domain is all x values that are greater than or equal to negative 2. Your range, once again, is your y-axis. And so the arrows are here, and it is going to continue to go up and down. So your range would be all real numbers. And then, is it a function? No, this one is not a function because you can look to see that there's this x value at 2 goes to 2 different y values. So if you have any x that goes to more than one y, that it's not a function. And this really happens all over this graph. You can see all these different points at negative 1. There's one here, one here. So this is not a function. So as I said, I answered a little bit more than what the question was asking on this one, but the extra practice could never hurt.